Hi, and welcome back to Hacker101. In this session, we're going to talk about the types of cross-site scripting and authorization vulnerabilities, as well as exploitation techniques for these. We've all seen cross-site scripting in action, from the very first session to all of the coursework, and this is because XSS is easily the most common bug you're going to encounter. The very first example you saw in this class was reflected cross-site scripting. User input goes up to the server and then comes back down to the client in an unsafe way. This is usually paired with CSRF bugs, as you may have seen in the coursework. Stored cross-site scripting is where input goes up and is stored on the server, and then is sent back later without proper escaping. This is similar to reflected cross-site scripting, just with a delay between when the input goes up and when it comes back down. This is also known as persistent cross-site scripting, because as that indicates, it is persistent. You may see cases where you're able to change text on a page, insert an XSS payload, and exploit a user simply by waiting until they go to that page in the future. The third type, which you haven't seen yet, is DOM XSS. This is where input from the user is inserted into the DOM without any proper escaping, allowing an attacker to inject arbitrary HTML and JavaScript. This can be an obvious form, setting inner HTML on a node, or a more subtle one, where the eval function is being used for DOM modification. Because the mitigation of reflected and stored XSS are almost identical, we're going to be talking about them together and then just talk about where they differ. Before you can do anything with a bug, you have to actually find it. As you've probably seen in the coursework, it can be hard to tell what's vulnerable and what's not. Here's a checklist that I like to follow to find out if something is vulnerable to XSS. Number 1, find where the data goes. If I put in a piece of data, where does it come out in the end? If it's stored cross-site scripting, I may try to figure out where it's stored. A database, file contents, or even a file name. But just try to get a feel for the flow of your data through the application. Does it get embedded in a tag attribute or in tag contents, a string in a script, an integer in a script? In those cases, you may be able to get direct JavaScript injection. Number 2, figure out how the data is handled. In level 1 of the coursework, you may have seen that URLs get turned into anchor tags, that is, links. And that kind of special handling of data is important. Anytime you have special handling, this is where things can fall down. Is the data being HTML encoded before it goes into the href field? It can't happen after the A tag is made, or it would destroy the tag. And then finally, number 3, figure out how special characters are handled. Insert single quotes, double quotes, angle brackets, semicolons, etc. Cover your bases in terms of what might be useful for exploitation. If one of them makes it through without encoding, make a note of that. If there was any special handling that you found in the previous step, make sure you test that case too. That is, if your URLs get turned into links, what happens if your URLs include special characters? Once you've gone through these steps, you'll have a pretty good idea if they're vulnerable to XSS or not. If you're in an attribute of a tag and you can throw in a double quote, you almost certainly have an XSS vulnerability. If you can't, you're stuck in the attribute and they're probably secure. Are you in a script? Can you break out of the string? If not, they're probably safe. If so, you've won. Do bear in mind that sometimes special characters will only go through if not as part of, say, a tag. In cases like that, try to see if you can just break out of an attribute and use a DOM event like onMouseOver. Here's where one of the difference between reflected and stored comes into play. If it's reflected and it's triggered via a post, proper CSRF mitigations will probably prevent this from being exploitable. If a post is required for the attacker on a stored XSS though, for instance changing text on a page, then CSRF mitigations don't matter at all. Let's just talk about a couple different exploitation cases. When you're doing the third step and you're testing special characters, you notice that your angle brackets make it straight through and are embedded directly into the text of a tag, the perfect case for you to exploit. A simple script tag will often get you a successful exploit. If there's a WAF or something else detecting script tags, just embed an anchor tag or use an image tag with a bad source and use the onError attribute. Few filters will ever actually work properly. If you can get any special characters in, you're probably going to win. A close variant of this is when you have your input being reflected in a tag attribute. Going back to level 1, your input for URLs is reflected in the href attribute of a tag. And you can get double quotes in, but not angle brackets. Well, we can just use a DOM event here. onMouseOver, for instance, will work great in cases like these. Not all HTML tags support DOM events, but the vast majority do, making this a simple way to gain execution. One of the big exceptions you may see is when you have a reflected cross-site scripting into a hidden input field. It takes up no space on the page, so there's no way to use on mouse over and the like. In level 1's case, we had reflected cross-site scripting and angle brackets were caught, so you couldn't break out of tags. The other interesting thing is that you couldn't use spaces. Not having spaces meant that the exploitation was a little less obvious. However, there's a fun trick with HTML parsing. Attributes are considered closed after their closing quote. You can lead right into the next attribute immediately after an end quote, and you still have valid HTML. And finally, one of my favorite cases. This isn't one I see terribly often anymore, but user input getting reflected into code in an existing script tag. This case provides a challenge when it comes to mitigation, as HTML entity encoding, what we usually recommend for this kind of XSS, simply won't work. It'll break legitimate use cases, since HTML entities aren't parsed in script tags. Additionally, simply escaping quotes and backslash characters like you normally would in JavaScript will actually fail too. Specifically, you can put in a closing script tag in place in that field, and then just place a normal XSS payload after it. Given that these techniques won't work to mitigate the bug, what can you do? Well, let's talk about mitigation of XSS in general. People often say, just escape your input and ignore the context. The escaping needs to be different for each context. HTML tag body, HTML tag attribute, and strings or other data in scripts. In the case of strings and scripts, you have two options. First, don't. Avoid this at all costs. You will almost certainly get it wrong. And then two, escape quotes and backslashes, and also replace angle brackets with their appropriate hex escape. Again, the chance that you'll fix this in most cases is slim to nil, so design around this in other ways. For instance, put this input into a hidden field and then read that from JavaScript. The one big exception here is if you have an integer or a Boolean value. In these cases, make absolutely sure that the input is the type before putting it into JavaScript. In fact, just convert it to that type yourself to be completely certain. Now let's take a few minutes to talk about the last type of cross-site scripting, DOM XSS. The biggest difference here is that with DOM XSS, the data may or may not ever even touch the server, so this has to be prevented 100% on the browser side. Let's look at a little code snippet. This code pulls the locale out of the hash in the URL, for instance, enus. If the location hash exists and has characters in it, it uses this as part of the creation of an image tag. Notice that it looks a whole lot like a reflected XSS, just on the client side, and that's because it is. The mechanics behind it are the very same. However, hashes don't go up to the server, they're client side only. So even if there's a WAF or other filter in place on the server, it has no impact or bearing on the exploitation of this bug. But here's the problem with DOM XSS. When you talk about stored or reflected, there are a couple well-defined ways to mitigate it, as you learned earlier. DOM XSS, though, can happen in effectively an infinite number of ways in modern web apps. That means there's no off-the-shelf way to mitigate these bugs. Generally speaking, just don't put user input into pages directly, ever. For instance, use inner text instead of inner HTML when you're putting content into the page. But really, consider a very strict whitelist for these cases. Now that we've got some XSS stuff out of the way, let's talk about forced browsing and improper authorization. In both cases, you have an authorization failure. For instance, an admin area where the root of the admin console is protected, but some specific function in it isn't. Or in level 1, you could enumerate IDs in posts and see others' data. These are things that your user shouldn't be able to see or guess. Though they're very close, I consider forced browsing, or a direct object reference as some may call it, to be cases where you can enumerate or guess values. Things like auto-incrementing IDs are great targets for this. Improper authorization I typically reserve for cases where the functionality is reserved for a higher privilege role, like an admin or a moderator. Some people group these into one auth-z, or authorization, to separate it from auth-n, authentication, bugs. Either way to go about it is valid. Whichever one seems clearer in context is what I'd go with. As I mentioned earlier, the permalink URL for posts in level 1 is really a great case of this. You will see that a post of yours has a low ID, and incrementing or decrementing that ID will give you other users' posts. Aside from just changing IDs, an obvious one, how else can we find authorization bugs? One of my favorite techniques is just to perform every action as the absolute highest privilege user I have. Once I've performed every action, I'll switch to the lowest privilege user I have. Then I'll replay those original requests, just swapping session tokens and such for the proper user, and see if they succeed. If they do and they clearly shouldn't be accessible to this low privilege user, then that's a clear bug. For instance, let's say I can edit user details from an admin panel when I'm an admin. I switch to the low priv user and I can see the admin interface itself is blocked. I get a permission denied message. But replaying the edit post message does succeed. I may be able to use this to change passwords, insert XSS payloads to compromise users or admins, or even use it for something complex like SQL injection. This technique seems obvious, but I find some really great bugs with this. The thing you're going to find is that most applications don't generalize their access levels in any reasonable way. So even if there's a single admin console entry point, every one of the sub-features there will often require a separate authorization decorator or the like. This means that testing every single entry point that you see is the key to success in finding these bugs. Now, let's do some quick wrap-up. In review, XSS has three types: reflected, stored, and DOM. Reflected and stored XSS are both very similar in mitigations. DOM XSS can't be mitigated in some generic way, and the exploitation will differ greatly between cases. And above all else, never put user input directly into the page. Forced browsing and improper authorization. Basically the same thing. Feel free to call them auth-z or direct object reference, whatever you want. The differences are really just how the bugs come about. If it's enumerable, it's probably forced browsing. And finally, here are a couple tricks to try when hunting for XSS. These won't find all the bugs, but it will certainly blow up a large number of them. Most of these are pretty clear, but one thing you may notice is that the first one doesn't use a script tag. There are two good reasons for this. One, an H1 tag stands out on the page and tells me where it's inserted. And two, many things will search specifically for the word script and block it. So this will get you around a lot of filters. Well, that about wraps it up for this session. Thanks for watching and happy breaking.